Hello again, grade 10s. Right, I'm going through class activity 2 on page 199. They have asked you to draw the magnetic field lines around each of these pairs. So the first one is just a bar magnet. Then we have two that are parallel to each other, another two that are parallel. Then we have some that are on the same line, and again on the same line. Each one of these is a different interaction, and I will show you how the magnetic field lines work around all of these. Okay, I want you to understand that this magnetic field lines are a 3D concept, so we are not looking at a Y and X axis only. There is also a Z axis coming out towards you, so everything will always be 3D. Okay, it's very difficult to show that. If you Google force fields, magnetic fields around a bar magnet and the interactions between two, you would be able to see some really nice simulations. But for grade 10, you don't need to know that. So around a bar magnet, we've already done this. You know, magnetic fields come from the north into the south, and from the north into the south. So that's a nice simple one. Remember, your magnetic field lines are closest at the poles, and therefore you have your highest forces, or your strongest forces, at the equator. They are further apart from each other, so I should show you like that. Closest at the poles, further apart from each other at the equators. So this is where your magnetic field is the weakest, around the equator or the center of the bar magnet. When we are looking at number 2, you can see that we have like poles that are next to each other. So what you should be thinking, like poles attract. So your north and south are going to attract each other, and this north and south are going to attract each other. Which way do we point our arrows? Is it the same both ways? You should be thinking our magnetic field always goes from north to south, and we can't just do the same arrows this side because we have to go from north to south, and this magnet would be attracted, as those are both oppositely charged, or not oppositely charged, opposite magnetic poles. Okay, number 3, they have asked you to draw the interaction. What would happen over here? This, normally it goes from north down to south. What would end up happening is that these would just go that way and be deflected away from, sorry, that goes down that way, and be deflected away from this side. So the magnetic field here would almost, that should be moving around that way. It would move that way and that way. You've got two like poles next to each other, two like poles next to each other. Therefore, they will not attract each other. They will repel. So this magnetic field would be deflected away from that because they are like poles. Right, number 4. We have, again, two like poles. So what will happen over here is this will be deflected away down this way. This will be deflected straight away. Okay, and this would be deflected straight away. Okay, it would obviously not be attraction. They are like poles, therefore it is repulsion. And in our final question, we have got a north to south. We immediately know that it will be attraction, but if it wants you to draw the field lines around it, you would need to make sure that your field lines are always working from north to south. So we would have a force of attraction going on between those two. You would also have, you could do something like that, okay, where the field lines that would go down that way are now deflected and attracted towards this south end of the opposite bar magnet. So please go and mark your activities class 1 and class activity 2, And I'm moving on to homework activity 1 now.